Welcome to the homework help day 1 of module 4 geometric and algebraic patterns. Problems 33, 34, and 35. For exercises 33 through 35, use the following information. Hydrocarbons are molecules composed of only carbon C and hydrogen H atoms. The simplest hydrocarbons are called alkynes. The first three alkynes are shown below. Problem number 33. Make a conjecture about butane, which is the next compound in the group. Write its structure formula. If we look at the pattern, for stage 1, there is one carbon. For stage 2, there are two carbons. And stage 3, there are 3 carbon atoms. Therefore, on the next compound in the group, we'll have 4, C4. Also, looking at the stage number and looking at the pattern, we can see that the number of hydrogen start at 4. Then as we go on the next stage is 6, and then it's 8. Therefore, based on this pattern, we can conjecture that there will be 10 hydrogen atoms for the next compound in the group, which is butane. I'll use this space here on the bottom for number 33 to write a structural formula. So again, we'll have 4 carbon atoms, and then they will be linked by 10, 3, 4, 5, 6, 7, 8, 9, 10 hydrogen atoms. This is the answer to question number 33. For number 34, it says write the chemical formula for the 7th compound in the group. Well, based on our pattern from problem number 33, for problem number 34, we know that if we're looking at the 7th compound, the number of carbons corresponds to the stage number. Therefore, we will have 7 carbon atoms. And we know that for each stage number, we had seen the pattern that is twice the previous one. So if we keep the pattern, we can see that there will be 14 hydrogen atoms. So here's the chemical formula for the 7th compound in the group. 35. Develop a rule you can use to find the chemical formula of the end substance in the alkyne group. For number 35, we're going to go ahead and concentrate first on the number of carbons. So we'll create a table. The independent variable will be the stage number, and the dependent variable will be the number of carbon atoms. Organizing our data, we will see that at stage 1, we had 1 carbon. At stage 2, we had 2 carbons. At stage 3, we had 3. At stage 4, we had 4. If we look at the first differences, it's going to be 1, 1, 1. Since the first differences are constant, we know we will have a linear pattern. So for the end term, we know that it's going to be 1 times 1, 1 times 2, 1 times 3, 1 times 4. Therefore, 1 times n, which will mean that we will have 1 times n atoms for stage n for this particular pattern. Looking at the number of hydrogens in the pattern, let's create a similar table. Same thing, we'll put our stage number. Our independent will be the number of hydrogen atoms. Let's collect our data. Stage 1, there was 1 hydrogen. At stage 2, there was, at stage 1, there were 4. At stage 2, there were 6. At stage 3, there were 8. At stage 4, there were 10. We can see that by the first differences are going to be constant, and therefore they're going up by 2. So we have a constant term of 2 times 1, which is 2, but we need 4, so we'll add 2 to it. So let's check. 2 times 2 is 4, plus 2 is 6. 2 times 3 is 6, plus 2 is 8. 2 times 4 is 8, plus 2 is 10. Therefore, at the end stage, we'll have 2 times n atoms plus 2, which will give us our rule for the number of hydrogens in this compound molecule. So therefore, our overall rule for the n term will be, the number of carbons will be Cn, and then the number of hydrogens atoms will be 2n plus 2 for number 35.